Okay, what if everything we thought we knew about the universe was just the surface layer? What if the cosmos wasn't just a static collection of laws and particles, but was actually an active, thinking system? A system that learns, that evolves, and literally tunes itself into existence. Today, we are diving deep into a truly radical new theory that treats the entire cosmos as a self-learning computer, an idea so profound it could completely reboot our understanding of physics.
This quote from cosmologist Vitaly van Schuren gets right to the heart of one of the biggest puzzles in physics. You know how the fundamental constants of nature, things like the strength of gravity or the charge of an electron, seem perfectly set for life to exist? Well, this quote suggests that's no lucky accident. Instead, those perfect numbers are the learned outcomes of a cosmic evolution. The universe is literally optimizing itself to create observers, like you and me.
So this is the big, provocative question we're going to tackle. What if the most fundamental layer of reality isn't matter? It isn't energy, but pure information. What if our universe is running one single, unbelievably massive computation? A process of learning that's been unfolding for nearly 14 billion years. Let's find out.
Now, to understand why a wild idea like this is even being considered by serious physicists, we first have to look at a really deep crisis right at the heart of modern physics. There's a fundamental conflict that strongly suggests our current models are broken, and that what we really need is a radical conceptual renewal.
Here's the problem in a nutshell. We've got two pillars of modern physics: quantum mechanics, which describes the world of the very small, and general relativity, for the world of the very large. And the issue is, they are built on completely contradictory, mutually exclusive assumptions about how reality works. One describes a fuzzy, probabilistic, non-causal world. The other describes a deterministic, causal, and very real one. They can't both be the final word.
Let's just dig into these contradictions for a second. Quantum theory is fundamentally based on chance and probability. It basically says there is no fixed reality down at the tiniest scales until we measure it. General relativity is the complete opposite. It's a theory of a real, predictable, geometric spacetime. So how can both of these possibly be true? Unifying them isn't just a tough math problem, it's a problem about the nature of reality itself. It forces us to ask, what is the true foundation of our universe?
So how in the world do you resolve a conflict that fundamental? Well, Professor Van Schuren proposes a pretty stunning solution. What if these two powerhouse theories aren't fundamental at all? He suggests that both quantum mechanics and general relativity actually emerge from a much deeper process, the universe itself, operating as one gigantic neural network.
And let's be clear, this is not just a cool analogy. The theory states that the most basic building blocks of our universe are the neurons and connections of this network. Everything we see, particles, forces, even space-time itself, is just an emergent property of this network learning and optimizing itself over billions of years. It's constantly trying to minimize its loss function, which is just a fancy term for a measure of its error or inefficiency, exactly like an AI getting better and better at a task.
This leads to a truly mind-bending consequence. Gravity might not be a fundamental force at all. To get this, think about a popular algorithm in machine learning called the atom optimizer. The reason it works so well is that it navigates a complex, curved landscape of data to find the best answer really fast. Van Schuren's theory suggests that the curvature of space-time, what we experience as gravity, is the physical version of that exact same principle. Gravity exists to help the universe learn faster. It's an optimization tool.
And this learning process goes even deeper than cosmic laws. It applies to the particles themselves. In this model, the reason every single electron is identical is because over billions of years of what you could call subatomic natural selection, they've all settled on the most stable, most efficient configuration. They've all downloaded the same optimal software for existing. Van Schuren even speculates that an electron's internal network could be so advanced that it has already figured out quantum gravity, a problem our best human minds are still struggling with.
Okay, so if the universe is a computer, what are its absolute base-level rules? What's its operating system? While the neural network model describes the dynamics of how it learns, we need another layer to describe the fundamental logic of what's possible and what's not. And this is where a really fascinating and compatible idea called constructor theory comes into play.
This quote highlights a really profound shift in thinking. Instead of defining reality with equations about what happens, constructor theory defines it by what physical transformations are possible versus which ones are fundamentally impossible. It treats information not as some abstract idea, but as a physical thing, a thing whose properties are actually shaped and constrained by physical law.
In essence, constructor theory aims to be the source code for reality. It doesn't describe what is, but rather the absolute principles of what can be. A task is either possible or it's not, and out of that simple binary, all the rules governing our universe emerge. And this is huge, because if we can understand that source code, that's the kind of blueprint that could let us engineer incredible future technologies, from true quantum computers to revolutionary new metamaterials with properties we can't even imagine today.
So what does this source code actually tell us? Well, first, it says that information is substrate independent. That just means the message itself is separate from the thing it's written on. The idea of a cat is the same whether it's stored in your brain cells, written in a book, or coded into a computer. The physical medium changes, but the abstract information doesn't. And second, it explains all the weirdness of quantum information by focusing on what's impossible. For example, the laws of physics make it absolutely impossible to perfectly copy a quantum particle. And that isn't a bug, it's a fundamental feature of reality, and it's the very principle that makes things like quantum encryption unhackable.
So this brings us to the elephant in the room, consciousness. If the universe is really just information and computation, where does subjective experience, that inner feeling of being me, come from? What's amazing is that these new physical theories don't just ignore this question, they tackle it head-on, and they try to define consciousness itself as a measurable physical process.
Right now, there are several competing scientific ideas trying to ground consciousness in physics, but they all share one critical goal: to treat it like a measurable property of the universe, not some kind of magic. Venturin's theory, for instance, suggests consciousness is simply learning efficiency. The faster a system gets at reducing its errors, the more conscious it is. Another big idea, integrated information theory, says consciousness emerges when information in a system becomes so interconnected that you can't break it down into separate parts. And then you have orchestrated objective reduction, which proposes it's a specific quantum process happening deep inside our brain's neurons. Three very different approaches, all aiming for the same destination: making consciousness a part of physics.
This leads us to another deep puzzle. If the quantum world is fundamentally fuzzy, random, and uncertain, then how do we all experience the same solid, shared, objective reality? Why do you and I both agree that the moon is there, even when neither of us is looking at it? Where does this consensus come from?
Well, the leading explanation for this is a fascinating process called quantum Darwinism. The core idea here is that the environment around a quantum system acts like a massive broadcast system. It makes countless redundant copies of information about the system's most stable or fittest state. We, as observers, don't interact with the fragile quantum system itself. We see the robust, mass-produced copies that are littered all throughout the environment. So how does this work, really? Just imagine a single quantum particle. The environment, all the photons bouncing off it, the air molecules bumping into it, is constantly making millions of photocopies of its most stable properties. This massive redundancy is what lets you, me, and a scientist on the other side of the world all read the same copy and agree on what we see. But here's the real kicker. This process isn't free. Objectivity has a physical cost. The universe actually has to spend energy to produce and maintain our shared reality.
Okay, so let's pull all these incredible threads together. What we have is a brand new picture of the cosmos, a universe that behaves like a learning computer, governed by the fundamental rules of information, and from which both consciousness and our shared, objective reality emerge. This isn't a static, finished cosmos that was set in stone at the Big Bang. It's a work in progress, an autodidactic or self-taught universe.
This diagram really captures the central theme of everything we've talked about: emergence. From the bottom up, simple local interactions and rules, like neurons firing in a network or tasks being possible versus impossible, give rise to all the incredible complexity we see around us. Space-time, gravity, particles, objective reality, and yes, even consciousness might not be fundamental givens of the universe. They are all emergent macroscopic structures that are built by a computational process happening at the deepest microscopic level.
And this isn't just a philosophical idea with no consequences. As this quote points out, it implies that the very laws of physics might not be eternal and unchanging. They could be part of an evolutionary learning system, perpetually being updated as the universe computes its own existence. Just think about that for a second. The laws of nature themselves might actually be learning and evolving over time. So, where do we fit into this cosmic computation? Well, the answer's pretty profound. It seems the same evolutionary pressure that perfects an electron's software is also what drives human civilization. Our technological progress, from the first stone tools all the way to artificial intelligence, isn't something separate from nature. It's a direct continuation of this universal drive to get better and more efficient at processing energy and information. This suggests we aren't just bystanders watching the show. We are an active, crucial part of how the universe learns.
And that leaves us with one final, absolutely mind-bending question to ponder. If our entire reality is a self-learning system on a grand journey of discovery, what is the ultimate lesson it's trying to learn? What is the final state it's evolving towards? And maybe most importantly, what part do we play in writing its curriculum?